In this video, we are going to discuss about different queues that are used by operating system, and what are different schedulers and what is the scheduling criteria. Okay, so in this video, the topic is scheduling queues. Thus, there are three scheduling queues we need to use. First one is job queue, ready queue, and device queue. Okay, so job queue, it consisting of all the processes in the systems. It consisting of all the processes in the system. Job queue is associated, if you have knowledge of this particular process state diagram, job queue is associated with your new state, that is your hard disk. Okay, so it is either it is called job queue or job pool. Okay, so as the process enter into the system, they will be put it into job queue. Then if a process is loaded into main memory, that particular process is put it onto ready queue. Okay, so a process that is put it onto ready queue means it is ready to execute onto a CPU. Okay, but it is ready, the process is ready, but it is waiting to executed by CPU. Okay, so this particular ready queue, it will be implemented as linked list, especially circle linked list, where head and tail pointers are there. Okay, as the new process are coming to system, they will be added to the tail, and first process will be added to head. Okay, then there is device queue. Each IO device or each device in the computer system will be having its own IO device queue. When a process needs some IO, okay, needs some input device or output device, the process will be sent from that CPU to or that particular IO device queue. IO device queue. Okay, right? So next. There are three types of schedulers are there. First one is long-term scheduler, second one is short-term scheduler, third one is medium-term scheduler. So these schedulers, long-term, short-term, medium-term schedulers will be, it is taken from your process state diagram. That is, initially all the processes are resided in your hard disk. Okay, and where they are put it, once a process or programs are started executing, they are put it into job queue. Okay, so long term scheduler is selects a process which are residing in job queue. Okay, and send it to main memory. Okay, and schedule it. It will be schedule it and it will be sent to main memory. That means the transition is changing from hard disk to main memory, because we don't know when the user wanted to execute a program. Okay, so until then the scheduler will not schedule the process, change loads the process into hard disk from into main memory. Okay, so that's why it is called long term scheduler. It will happen very rarely, that is less frequently. Okay, because it is the user who actually decides when a process has to be executed. That means if you want to execute a C file, that particular file you need to double click on it so that it will be it will start executing. That file will be open. If you want to open a Word file, that means Word application, you need to double click on it. Okay, until and unless you double click on it, it will not move, it will not activate it, it will not be enabled. Second one is scheduler. So the states associated with long-term scheduler is new to ready. Then the state associated with short-term scheduler is ready to run. That is, the transition will happen from main memory to CPU. The process, the CPU will only takes the processes which are resided in main memory. CPU does not interact any device directly. Okay, it only interacts with main memory, that is your RAM. Okay, and there are processes which are resided in ready queue. They are ready to executed by CPU. This short-term scheduler will schedule a process which are waiting in ready queue and loads into CPU, which will actually select which process has to be entered into CPU next. Once the process is going to CPU, it will find which process has to be executed next. Okay, it will select which process has to be executed next. So with the time P1 is coming out of CPU, P2 will be scheduled to CPU. P2 will be scheduled to CPU. Okay, right? And this particular short-term scheduler has to be very fast because the process switching or context switching will be done for every 10 microseconds to 100 microseconds. It is very that it is very fast. Okay, the short-term scheduler has to be very fast so that the next process will be moving on to ready CPU. Okay, then there is something called medium-term schedule. Medium-term scheduler will be happen in two, in a case, that is swapping. That is swapping. The first case will be swapping. What is mean by swapping? This particular RAMs that we are using that has very limited storage capacity, 1 GB, 2 GB, 4 GB, or 8 GB. At a time there are multiple programs that is stored onto this particular RAM. Okay, so it is impossible to load all the process that are ready to executed by CPU. So if a new process come, PX is coming to system, then this has to, it is having a high priority so that it has to be executed. Suppose that the currently executed process in CPU is P1. So PX has to be executed because it is having highest priority. So PX has to move from CPU, move to CPU, but there is no place in main memory so that it can move to CPU in the main memory, so that this PX will be scheduled. So what will happen at this particular point of time? We'll find some particular process PY or PY. So this particular process will be moved from main memory to your hard disk drive, and this particular PX will be stored into PY place, and P1 will be sent back to main memory. PX will be loaded into CPU. Okay, once PX execution completed or any one of this particular process execution completed, this particular PY will be moved on to hard disk, again loaded into main memory. Okay, so the process of sending a process that is resided in main memory is called swap out, and main memory to hard disk is called swap out, and the process of sending a process from hard disk to main memory is called swap in. So this will happen when the process, then the main memory is full and there is no place to allocate for new process. Okay, so this is called medium. At this particular point of time, the medium term scheduler will come to action. Okay, so medium term scheduler, we don't know when this particular thing will be happen. It is usually either, then in the second case the medium term scheduler will come into action. First case will be swapping. Second case is when a process needs IO, that is a process is executing on CPU and it has to print some 10 pages or 20 pages, so it needs some IO to be happen, then we'll use medium term schedule. Okay, either one swapping, or two, when a process wants to move to IO device, we'll use medium term scheduler. Okay, the next one will be CPU scheduler. A CPU scheduler will select a process that is resided in ready queue and send it to CPU. So it will select which process will enter into CPU next. It is called CPU scheduler. Then the dispatcher is the actual module. Dispatcher is the actual module which will be used to send dispatch the process from main memory to CPU. That is, what are the process that is selected by CPU, that is P1, P2, PX, PY, PZ. Suppose PX is selected for CPU next, then the dispatcher module will send that particular PX to CPU. Okay, that is actually dispatched by dispatcher module. Preemptive scheduling. What is mean by preemptive scheduling? A process P1 has a set of instructions I1 to IN, all the instructions has to be executed. That includes even IO operation. That is, it needs to print 100 pages of printout. Then the process that is resided in CPU, that is occupied by CPU, it will occupy it until and unless its all instructions are executed. That means I99. Then it has to print 100 pages. Then I100, instruction 100 is executed until and unless it won't leave the CPU, is called non preemptive scheduling. It is called non-preemptive scheduling. But this will gives a problem to the system and performance is decreased. So what we did, this problem is overcome by using either multi-programming or multitasking, where the process is not completely executed. That is, either the process is went for IO or a clock interrupt will be occur, so that the process change will be happen, the context switch will be happen. That is, even though the process is execution is not completed, we are loading the next process to CPU, is called preemptive scheduling. Okay. Now the scheduling criteria. Okay. So in scheduling criteria, there are 5 criteria we need to be make sure. First one, CPU utilization, throughput, turnaround time, and waiting time, response time. Okay. So what, CPU has to be busy at all times. So whenever there is CPU is idle, we need to load one particular process to CPU, and this CPU utilization is ranging from 0 to 100. In general, we need to maintain 40 to 90%. CPU has to be, utilization has to be maintained in between 40 to 90%. Okay, so this CPU utilization must be maximized. That means we need to execute more number of processes so that the CPU is utilized better. Okay, then next one is called throughput. What is the meaning of throughput? It is the number of processes that has to be completed within a unit of time. Okay, so suppose that if you have one unit, in this particular 1 unit of time, you have been executed X number of processes. So your throughput will be X. So in 1 unit of time, that is 1 millisecond or 10 milliseconds of time, you have executed 10 processes, then your throughput value equal to 10. Okay. So this particular throughput has to be high. That is, you need to maximize the throughput. You need to maximize the throughput as well as you need to maximize CPU. The next one is turnaround time. It is the time at which the process come to your system, that is arrival time of the process, and it is the time at which the process has completed its execution. That is CT minus AT, completion time minus arrival time. That is, it is the time at which the process is generated and the process is finished its execution. Then there is something called waiting time. This waiting time means it is the amount of time the process is spending on ready queue. Okay, there is a formula for waiting time, that is waiting time equal to uh, turnaround time minus CPU burst time, that is execution time. CPU execution time. That means we need to remove CPU execution time from the total time of the process. Okay. Then there is something called response time. That is, it is the time at which the process is came to ready queue, that is came to system, and at the first time the process is scheduled to CPU. Not, we are not considering considering when the process is terminated. It is the first time the process is scheduled to CPU. That means the process came at time t equal to 5, then it is scheduled at time t equal to 7. So the response time will be 7. Okay, that means it took 2 seconds to send that particular process to CPU. The waiting time will be only 2 seconds. Okay, so we need to maximize CPU utilization, throughput, and we have to minimize turnaround time, waiting time, and response time. We'll see how this will work in the next video.